Figures 10.1 through 10.3, const objects and const member functions. We previously have introduced the keyword const for declaring something that should be treated as a constant. And it turns out that objects of a class can also be treated as constants, and when they are treated as constants, the C++ compiler is going to make sure that any operation we perform on such an object does not change the contents of that object. Now, the problem is if you don't properly construct your class to accommodate the compiler ensuring that an object remains constant when it's declared to be constant, then you may actually wind up getting compilation errors that are hard to understand and also not be able to use your class the way you think you should be able to use it. So what we have here is an example to demonstrate how to use the const keyword with member functions, and specifically the idea here is to say if a particular member function does not modify an object of the class, that it is a const member function, and that is a guarantee to the compiler that within the body of that function, the object of the class will not be changed in any way. Now, if you look at the interface for class time, again, we have our private data and then our public interface. The interface is the same as the last robust version of class time that we did, where we first introduced the set and get member functions and also the updated time constructor. But the difference in this example is that our getHour, getMinute, and getSecond member functions each has after its parameter list the keyword const. And what this is saying is that this is a const member function. In other words, when we call getHour, the state of our object, the hour, minute, and second variables, will not be changed in any way. We'll simply be reading data out of the object. And the same is true for getMinute and getSecond. Now, we can't do that for setTime, setHour, setMinute, and setSecond because if we were to declare those as const, we wouldn't be able to modify the hour, minute, and second when the user wanted to set the time or individually set the hour, minute, and second. So only member functions that do not modify an object of the class can be declared const. Now, down at lines 24 and 25, we declared the print universal member function const, and we did not declare print standard as const, and we did that on purpose in this example to show you that we get compilation errors when we try to call this function on an object of class time that is currently a constant object. And the reason we're doing this is to prove to you that even though we know print standard doesn't modify the contents of a time object, the compiler will not allow that function to be called on a constant time object because it is not a const member function. On constant time objects, only const member functions can be called. On non-constant time objects, all the member functions of the class can be called. So let's take a look at our time.cpp file, and you'll see that for each of the member functions that we declared as const in the header file, we also have to specify that in the source code file as well. And one of the reasons for that is that one way that you can overload member functions of a class is that you can have a const version and a non-constant version of the same member function. And we'll do precisely that when we get to our discussions of operator overloading in a later lesson. Now, here we're saying that getHour is a const member function, so inside the curly braces of this function, we cannot have any statements that modify the instance variables, or the data members rather, of our class. Hour is one of those data members. So if we were to try to modify hour in here, we'll get a compilation error. Now we do the same thing for the getMinute member function, declaring it as const, again, after the parameter list and before the body, and same thing for getSecond. Also for print universal, we've declared it const, and again, we should put const here on line 72 after print standard, but for the purpose of this example and to demonstrate compilation errors that we want you to see, we've purposely left off the const keyword for the print standard member function. Now let's take a look at our figure10.3.cpp file. And basically what we're doing here is declaring a couple of time objects, one called wake up, which is set for 6:45 in the morning. And this is a non-constant time object, presumably because, let's assume we were using this with some sort of alarm clock class, we would want to be able to modify our wake up time based on each day when we want to get up. On the other hand, we have a constant time object called noon, which is set to 12 p.m., 12:00, and that is always going to be the same time. Noon is always 12 hours, 0 minutes, and 0 seconds. So we've declared that as constant so that it cannot be modified in the program. Now, at line 11 here, we have a member function call for the wake up object. We're saying to set the hour to 18. Now, this is allowed because the object that we're operating on is a non-constant object. We're just putting this in the comments on the right so you understand how each function is being treated here. We have a non-constant object and we have a non-constant member function. You can always call a non-constant member function on a non-constant object to modify that object. So wakeup.setHour is allowed by the compiler. On the other hand, noon.setHour is producing an error message, and you can see the red squiggly, and if I hover over that, it says error, the object has type qualifiers that are not compatible with the member function. Now, unfortunately, that's not a very useful error message, but this is one of the reasons why we want to show you such an error message, because when you encounter problems like this, eventually you'll become familiar with the error messages generated by the compiler, and that will help you eliminate the errors from your program. Now, the issue here is that we have a constant object, and we're attempting to call a non-const member function on that object. You can never call a non-const member function on a constant object. And the reason for that is the compiler only allows const member functions that are guaranteed not to modify the object, to be called on a const object. So this line is going to generate a compiler error. And in fact, if we try to build the solution, you can see that line 13 is generating an error. It says setHour cannot convert this pointer from const time to time reference. And when we talk about this pointer in a couple of the later examples in this lesson, you'll understand why that error message makes sense. Now let's go back to line 15 where we have wakeup.getHour. Wakeup is a non-constant object as declared on line 7. GetHour is a const member function. Now you can always call a member function that doesn't modify the object on any constant or non-constant object. Again, it's not going to do anything to the object other than get a value out of the object. So this is allowed to compile because wakeup is non-constant and you can call any of your class's member functions on a non-constant object. On line 17, this also compiles because noon, a constant object, is having its getMinute member function called, and that was declared as a const member function. We have guaranteed the compiler that getMinute will not modify a time object, therefore the compiler allows line 17 to compile. Similarly, line 18 can also compile because noon, a constant object, is having its printUniversal member function called, which is a const member function that has guaranteed the compiler that it will not modify the contents of the time object. If we attempt in any of these member function definitions to modify the object, the compiler will actually generate a compilation error, preventing us from compiling the program and running it. And then finally, line 20. Now let's look at the print standard member function again. And when we, let's try that one more time. When we go to the print standard member functions definition, you can clearly look through the code that's here and see that at no point are we assigning values to the hour, minute, or second data members. We're never modifying the contents of our time object. However, because of the fact that we did not declare this as a const member function, the compiler is complaining about line 20, even though we know it won't modify the object. If you do not declare a member function as const, that is guaranteed not to modify the object, you cannot call that member function on a constant object of the class. So it is actually a good software engineering and programming practice for every single member function that doesn't modify objects of your class to declare those member functions as const member functions so that they can be used in situations like line 20 where we have a constant object, and right now we can't call print standard because it is declared as a non-constant member function. So again, the compiler in C++ is very particular particular about const and application of const, it is always going to enforce the const keyword to the level of even an individual object that might not be declared constant initially, but maybe we pass it into a member function that receives that object and treats it as a constant object. Inside of that member function, we would only be able to invoke member functions of the object that are declared to be const. So from this point forward, when we declare our new classes, any member function that doesn't modify objects of the class will be declared as a const member function.